Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to explore the outbreak on Monkey Pox, right? So as you already know, Monkey Pox is a zoonotic virus. That means that it is transferred from animals to humans, right? So this is something about it, right? Some basic stuff about the symptoms and the science, right? Okay, so let's see how to use Python to analyze it. We're trying to use Python to do some simple data analysis on the Monkey Pox virus outbreak. So our data set is gotten from global.health, which is coming from here. So if I go back to GitHub, we have global.health monkeypox. So this is where I'm getting the data set from, right? So credits to them, and then they have several of them. So some of them have been archived, but the source of the data, the main source of the data that is being updated every day is the direct one, right? So you can get the JSON or you can get the CSV. So I'll copy this one here, right? Copy this link, and then you start writing some code. So by the end of this tutorial, I'll be trying to see how to derive some simple insight from that. Trying to see how many countries have been affected, the number of cases, the confirmed suspected cases, top countries affected, distribution per continent, the number of cases per day, most common symptoms, and the rest. So let's see what we're doing. So first of all, I'm going to import our E.Agbe packages, Pandas and NumPy, and our data visualization packages, Matplotlib, Seaborn, and Plotly for the interactive plots, and then some other packages, right? So let's start running some stuff. So I'm just going to go back here, going to create some cells. Apologies for how it's going to be, and in case you have any question or contribution, you can also put it inside the comment section below. So let's load our data set. So this is going to be my data URL, the one I got from here, right? So this is the data set coming from GitHub. I'm going to load it, and I'm going to load that particular data set. So df is going to pd.read_csv data URL. So this one is coming live, right, from GitHub. So let's explore it. So df.head, and then we can see the dataset well, right? Very nice. So we can see that the dataset is having an ID column, a status column, a location column, cities, countries, age, gender, data onset, and the rest. So we're trying to see how to derive insight from there. So based on this, we can get some information about the number of confirmed cases, right, and the number of suspected cases based on the status. We can also find which of the cities is mostly common, the countries, the age, and then the rest. So let's see how to do that. So let's start with the first one. So I'm going to check for the shape of the data set. How much do we have? So d.shape, we have about 939, right, here data points for now, because it's very recent. My screen will be going up and down because of my laptop and my mouse. Yeah, because of my movements, I need to get some new stuff. Okay, so let's check the data types. So df.d types for the entire data set, we have all of them as objects and the ID as integers, right? So the outcome, the date, there is some date columns which we have to convert to datetime index to do proper time series analysis, and then we also have some travel history and some rest, right? So let's move on from here, and then let's check the number of columns that we have, right? Now to check the columns, so this is going to be the columns. These are all basic stuff. So df.columns. So these are the columns, right? So based on this, we can check the location. So let's ask some of the questions, see and explore some of the questions we can ask based on these things. So if we have something like city or country, we can know the distribution of the cases per country, right? So let's try that one out. So that's going to be the first one. So this is going to be on the EDA, and then in this place you are going to be working on the distribution, right? So distribution of the cases, right, per location. So location here, we are referring to country, we are referring to city, right? So these are the stuff you'll be checking on. We'll check the distribution of cases per the location. So let's try that one out. So the first one is that this is going to be distribution per country, right? So simply just go with df, right, and we have the country column. So that is distribution per country. But before we get on a distribution per country, I want to know how many countries have been affected, or how many countries are within our data set, right? So that is going to be how many countries in our data set. So how many countries in our data set, right? Because not every country is reporting their cases, right? So you just go with this. So this is going to list all the countries that we have. So we have England, Portugal, Spain, United States, Canada, and I can check for the number of countries. So this is going to be the number of countries. So length of the DF, the country, right, dot unique, and then our closest. So this is going to give me the number of countries. So about 44 countries have been affected, right? This is what is based on this particular data as of now, right? Out of the 200 and something countries we have in the world. Okay, perfect. So we have gotten some information about it. Now we also want to know the distribution per country, right? So let's go with this. So to get the distribution per country, how many cases per country, right? So in that case, it's going to be like this option. You can simply do, there are several ways. You can just go with df.country. You can use value count dot value count. So this value count here is now going to be checking per the case. This is either it is confirmed. In this case, this is going to be either confirmed, suspected, or whatever, right? Whatever it is. So this is just based on the data set, right? So distribution per country. So Spain is at the highest based on this. So you can actually visualize this using Seaborn. So let's visualize it well. So I'll be using Seaborn to visualize of distribution per country. So this is the number of cases per country, right? So that is cases per country. So in that case, it's going to be this option. So cns.count plot. Then I'm going to pass in my S, which is going to be the country column, and then I'm going to pass in the data. It's going to be df. So if I plot this one, it's going to come out very small. So I can just go with this option. So plt.figure to give it the figure size. So figure size, and then this is going to be 2010. I can make this one into a function so that I can use this particular plot over and over again, right? So that is something I can also do. So this option here, then I have to close, yeah, and then I can just go with plt.show. So if I go with this, it's going to plot it perfectly for us, right? So let's see our plot. Perfect. But you can see from here that this is not right? You can't see the country's name. So we can actually make it simple by going with this option here. And come back here and then set the rotation. Apologies for it being small. My mouse. plt.s text, right? Then I'm going to set the rotation to be equal to, let's say, 45, right? So now if I run it, it's going to give it in a clearer format. Okay, so based on what we have so far, we can see that England has the highest, followed by Portugal and then Spain and the rest. So this is just the distribution, right? So using Seaborn, we can also use Plotly Express to plot this one in a nicer format so that it becomes interactive. So we'll be trying to explore that one later. So let's see how to use Plotly to also plot the same thing, right? So that at least you learn two different approaches. So this is not interactive, but it's going to be interactive. Plot of the distribution, right? Cases per country. So using Plotly, this one I'm using Plotly. So in that case, it's going to be like this. We have our Plotly already imported. So figure. First of all, let's get our data. So let's call it as my cases. So it's going to be my df dot group by. Then this is another way you can also get a value count to country. Then we are going to get per the status, that is the most important. Then count, right? So this is going to count the entire stuff and give us per the country and the count. So as you can see, then I can just go back to reset index. So reset index, so that we have it as a proper data frame. I can now put this one into my cases per country, right? Let's go to cases per country. Perfect. And now I can just go back to this. So cases per country, and you can see the data frame, right? So the country and then the data frame. I can also just pick this one and then just make it like this. So we have the country or the status. Yeah. You can also use .n largest. So n largest. Sometimes, yeah, it's going to bring the largest countries there, right? This is one of the ways, or you can just do it this way. N largest, then you pass in the column that you want to use. So in this case, I want to use the status column. Hopefully I'm not wrong with this. Yeah, it's giving us an error. So missing one argument. So columns. Yeah, perfect. It's giving us an error, but yeah, that is one of the ways of doing it. Let me check it out. But as you saw, yeah, it's supposed to be this way, right? This one worked perfectly well, but I wanted to get the actual names here. So it's simple, like this is one of the ways. The other way is just do this option instead of this here, right? I'll just take off this for the data frame. I'm going to pass in my number of that I want. So let's say I want to get the top countries. So this is going to be the top countries that have been affected. Yeah, 10, right? And then my column. So columns is going to be this option here. Right? So we have the status column, which is what I'm using. Now if I run it, and now we are seeing it in a better format, right? So this is cases. That is top countries affected, right? Or with reported cases. So that is the basic understanding. So we are just using n largest. We first of all group them, then we are using n largest to get the top countries affected, which is Spain is the highest, followed by England, Portugal, Canada, Germany. Wow, Germany has 48, France has 33, Belgium, United States has 19, right? So this is top 10 countries affected. So we can actually plot it. Since we have gotten it as group by, we can plot it. So let's do a simple plot using Plotly. In that case, it's going to be like this. Our plot is going to be figure, then PS, right? Plotly Express bar. I'm going to pass in my case. I'm going to pass in that particular column that we had. That is the cases per country. Yeah, this one. Yeah. Case per country, and then I'm going to pass in my S, which is going to be the particular country column. Then the Y is going to be my status, which is the count, right? Then I also want to give you some color, so let's add the color using the country name as the color. Then perfect. So this is all that I need. So if I run this, so figure.show, now I can see my plot in Plotly. So this is interactive, and then we can actually use this one in Streamlit plot. So we'll be using that one later on when we are building our app for this task. So as you can see from here, we have Argentina, Australia. This is in alphabetical order. So Spain is the highest for now. Portugal is also there. There is also England. There is Canada, and the rest, right? United States, Germany. I don't know whether there is Nigeria or India. Yeah, but like you can see from our result, right? Perfect. This is because of what is being reported, not what is actually happening. This is what is based on this particular data set. Perfect. You have seen how to get the distribution per the country. We can also do the same thing per the city, right? Because we can see that we have some city column here. So we can also do the distribution per the city. We can also group them in every country, which city is mostly affected. So let's go back and see if we can do that with the largest countries here. So we'll be checking for Spain and then England. I want to see which cities in Spain and England have the largest cases, right? Oh, yeah. So in that case, it's going to be the next one. So all of these things are off-head. I'm just exploring it off-head. So let's go back here. It is going to be which cities in the top countries, in the top affected countries or reported countries, right, have the most cases, right? That is the basic understanding. So this is going to be per the country, per the city. So let's go first for England. It's going to be for England. In that case, it's going to be the same thing we did. We had the cases, but it's going to be my df dot group by group by, right? I'm going to group the entire stuff by the country, right? So this is one of the ways you can do it. You can actually use group by, and you're going to group everything by the country, but you can also use this option, get all the countries. So we want the country, right? Yeah, we want every part of the country that is equal to England. So the country is equal to England, right? So this is going to give us a data frame. Let's twist this option. Okay. Oh yeah. So it's supposed to be this way, right? The reason it failed was it's supposed to be this option here. You first get that row alone, then after getting the row, you are going to get the entire data set. Right? So this is how it's supposed to be. And now it works, right? Perfect. So these are all the columns or the data points that is having the country England, right? Perfect. So this is going to be for only England. And now I can also do the group by. So group the entire stuff by the city, right? So group by city, right? So this is going to be grouping by the city, and I can just go with the status, right? And then I can just go with the count. So if I go with this option, this is going to give me per the country, and then so London is having the highest, Newcastle followed by South East. I don't know what South East is. So this is for only England. You can also do the same thing for the other ones. We can do for Spain. So this is going to be which countries. So in every country, like London and co, like yeah, we have these ones there, right? You can also do the same thing for. Let's come back here. Yeah. So the reason I'm using status is that is what is called. It's mostly populated with. So this is going to be for Spain. So which countries in Spain, right? So I'll change this one from here to Spain. So let's check it out. Wow, so Spain has a lot of countries with it. So as you can see from this, you can see that in Spain there is Madrid. Madrid also has a lot here, right? Wow, so there are a lot of cases in Madrid and a lot of cases in Gran Canaria, right? Perfect. So this is something. So let's check for US, United States, and then we'll check for yeah. So this is going to be for United States, right? Let me see how it was spelled. The countries that was spelled is United States, right? So United States, United States. Right? So this is going to be for the US. Right? Let's check it out. Okay, so New York 1, Denver 1. So this is based on the status. I can also take off this. If I take off this and then I run it, this is also going to give us in this particular format. Yeah, right, the same thing, almost the same thing. Right, perfect. So we can also use the size instead of just the count. We can also use size, which is also going to give us the same. So either they use the count or the size, any of them is going to work. So we have seen which cities in the top reported countries have the most cases, right? And we saw that in Spain, right, it is Madrid. In Germany, it is in England, it is London, right? Okay, so let's see for right. So perfect. So let's move on from here. We have seen some simple stuff on the countries affected and then the cities most affected. We can also do the entire stuff for the entire cities, right, of the world. So in that case, it's not going to be this option. We're grouping by the city. So group by city, right? This is going to be which cities have the most cases, right? So this is going to be which cities have the most cases. So there's Aachen. Oh, Aachen is in Germany. Wow. And then the rest. So we can, this is one of them, but we can also do reset the entire stuff. So reset. We can, this is one way. Yeah, this is okay. We can also do this option. This method 1. Let's go to method 2. So this is going to be method 2. And then we just do some plot and then we move on, right? So apologies for how long this is going to be. So method 2, and this is going to be df. This time we're using value count, so I'm going to pass in a city, and then dot value count, right? So this is another way. And if I run it now, you see that Madrid is having the highest. Wow, followed by Berlin. I'm surprised. Followed by Lisbon, and then we have Toronto. So this is per the data set, right? Not whether it is confirmed or it is suspected, right? This is per the entire data set. In case I want to check for not just the status but the different types, let's do that one out. You can also plot this one. Let's plot this. Plot. There's another way you can also plot it. Bar. And it's also going to be very small, but you still manage it like that. So let's see that I was able to plot it here. As you can see, it is so crowded, right, with a lot of countries there. So we can make it bigger. So plt.figure, then figure size 2010, and then we can let's go with the same thing we did. So I have to close it, and then just go with plt.show, right? So this is one of the ways of doing it. So yeah. So it's going to work perfectly for us. Okay, perfect. So we have seen which cities are the most affected. You can see that Madrid is more affected. There is Berlin, and you can also make it an interactive plot. So what I'll do is that I can actually create a function, or create a function that gets everything and then make it simple for us. That is also another way you can also do that, right? So I can also create a function like this. So let's come back here, copy this one. This is cases per city. So cases per city. Per city, right? Country, right? So yeah, the entire cases, whether it is confirmed or not. So this is either confirmed or suspected, all of them, right? Or otherwise, right? etc. Okay, so that is why we are getting that, and now I can actually get it out. So cases, the same thing we did. So cases per city, I'm getting it perfectly well, right? And then I can also plot it using this, what we did above. So let's go back here. Okay, so I can just come back here. To make it simple for us to plot, I'm just going to convert this one into a function. So anytime you're using it, you just run it with that. So this is going to be my function plot. Yeah, let's go to plot distribution. Okay, and now I'm going to pass in the same thing. So this is going to pick in the data, right? And also going to pick in the column and then the y, right? Something like that. And now I can just bring it here. So this is the plot you're doing. So the cases per country is going to be the data. Make it bigger so that I can see data, and then the country is going to be the x, and then the status is going to be the y, right? And then the color is also going to be the x, right? Something like that. So anytime you are plotting, you just pass in these values and then we can plot it perfectly well. So let's plot the distribution. This is going to be an interactive plot. I'll pass in my cases per city, and I'll pass in my s. So this time my s is going to be the country, as we did, and then the y is going to be the status. Yeah. Okay, so let's plot it and see. Taking some time to plot it, right, because it's quite huge. Yeah, perfect. So we have seen it all, right? You see, Spain has this number of cases. This per the country and the status. This per the country, right? But we need a city, not a country. So I have to go back and then next time changes. So this was city. Somebody should have told me. So city. I plot it now, it's going to come perfectly well. So in case you have any question or contribution, you can put it in the comment section below. Yeah, perfect. So we can see from here that the largest country there, we have Madrid is having 121. We also have Berlin 25. We have Hamburg. We have Granada. We have, I have no idea of this, Toronto, that is in Canada, right? 19. Right, so you have seen how to do this simple plot. Perfect. So let's move on from here and do some other plots. Perfect. So this is just in general. Now let's see the confirmed cases, right? Because if I go back to my data frame, this is for only confirmed cases, right? So if I go back to my data frame and I go with my status, right? So before we go to the confirmed cases, let's check the status first before. So there's going to be status. So there's going to be distribution. It's going to be my df, the same thing we did. Let's use cbond sns.count plot, and I'm going to pass in my s is going to be my status column, and then my y, or my data, not my y, is going to be my df. Right, if you run it, yeah, so we have confirmed, there are a lot of confirmed cases, that is about 700, and then discarded, status, and then suspected, right? So we have a lot of confirmed cases, right? That means that it's going up. So we can actually do the same plot we did above, but now for each country, which is going to be a lot. Perfect. So we have gotten the cases, right? The status, right? So there are a lot of confirmed cases, more than that. But what I want to do is I want to get the individually, right, for every country. So we already saw the top countries that were affected, which is these countries here. Come here, let's go back again. The countries that were affected the most, right? We had Spain, England, all of these countries here, right? These were the ones that were affected the most. So I want to get the distribution for these first countries that were affected. That is one thing we're doing. So let's first of all get the entire distribution. So the first one is, it's going to be how many, different types, status per each country. And that's the first one. So in that case, it's going to be the same thing. So df.group by, I'm going to group by the status. So the status, and then I also want to get it by the country, right? So we get the country and the status together. Then I can just go with the size. If I go with this, I'm going to get the entire stuff. So for every sub status, right, that is confirmed, this is the distribution, right, for them, and then for the discarded and for the other one. But this is okay, but sometimes it's better we plot it, right? So it's better we plot it. Okay, so let's see how to do that. So I'm going to do the same thing for the entire plot. So I'm going to get the top countries. So let's get the different types of the status, the top affected or reported rather cases, right, per country. So that's what I'm trying to do. So in that case, I'm just going to do the same thing we did. We got df dot the country, right, and then we got this one as the value count. This one gave us these ones, right? But in case I wanted to get these ones, the top one, that means I could have done something like this. So this is to frame. This is converted to a data frame, and I can just go with this option of n largest, right? I'll pass in the top 10 countries that we have. Then I'm going to get those particular values, right? The column that I want to get the country. Yeah, perfect. So these are the countries, the top 10 countries. I want to plot for these top 10 countries, right? So in that case, I can just get this thing, the names of the countries as a list. So this, right, and we have the country. So this is going to give us only the country. Then I can just go back to the list. Hopefully it works. No, this is not what it's going to give to us. I want the index. So in that case, it's going to be index. Oh, see what I did. Why did I put this one here? But index. Yeah. So this is it, right? So these are the countries that I want. So I can convert this entire stuff. So this is the top affected countries, top affected or top reported, because countries, right? And then I can convert this entire stuff to a list. So let's convert this thing to a list, right? Because so we have it well. So top reported countries. Yeah, now we can actually plot this one. So how do we plot this one? So we can just use Seaborn to get that particular one. So in that case, I'm not going to do this group by. We remember that we did this group by, right, for the entire stuff, but we want to pick only for those countries that are found here and then do the group by for that. So it's going to be this option. So df country, right, it's going to get all the countries. Perfect. And I'm going to say that okay dot is in, I'm not sure here, or string contains. There is also string contains. Yeah, there is also is in, right, or string contains. So the top country that we have, which is in this case going to be top for the countries, can get the true or false, right? Then from there I can just get the only those ones. Yeah, see, my mouse is misbehaving. Apologies for that. That's why it's becoming bigger and smaller as we go down. So now I can get only the data set, right? So this is only for the top reported countries. So this is going to be for the top reported countries. So this is going to be top countries. Yeah, as a data frame. And now I can now use the same function that we did above, right? So we can just use Seaborn to plot it. So sns dot cut plot, right? And I'm going to go with my data. It's going to be my top countries df, and then the kind is going to be count. You want to count the entire stuff, and my s is going to be the particular column I want to count. It's going to be the country. And then let's give the hue to be the status. So this is another way of plotting it. So let's plot it out. So I'm getting the cat plot, right, categorical plot, and as you can see, we have it in a very nice format. I can make it bigger so that you see it well. So let's plot it again. I just added the size to it so that it's plotted in a better format. Hopefully it did not do that. So I have to just add this size here, right? That is why I did not plot it well. Yeah, right. Perfect. So this is better. At least you can see it well. So you can see for every country. You can see that there are a lot of, in England, there's a lot of confirmed cases in England. That is represented by the blue. For Spain, we have all the different demarcations, but there's still a lot of high confirmed cases. For Germany, there is discarded, suspected, and then there is, as you can see from these plots here, right? Very nice. So we are done with most of the plot for some of them. Let's see the last one. So I'll be answering some of them and then you continue later on, right? So let's go back again. So I've seen how to do most of these things. 1, 2, 3, distribution, number of cases. Let's go to the number of cases and then the most common symptoms. So let's go back again to the most common symptoms and then move on to the number of cases per day, right? So let's go back again to this one. So this is going to be another one on the number of symptoms per day. It's going to be number of symptoms, so number of symptoms, not number of symptoms, but let's say frequency of symptoms. So frequency of of symptoms. Which symptoms are very frequent, right? Reported symptoms. We want to know all the symptoms or the symptoms in hand. So this is going to be what are the symptoms reported, right? So in that case, we have, if you go back to our data set, you can see that we had a column that had only symptoms, right, which is the symptoms here. So I can just go back again and get those symptoms column to get every part of the symptom. So dot unique is what are the reported symptoms. So this is going to give us a list of all the reported symptoms. So these are all the symptoms that have been reported, right? So we have rash, we have vesicular rash, skin lesions, ulcerative lesions, fever, genital ulcers, as you could see from the image here, right? So we have fever, there is rash, there is swelling lymph nodes. So let's see if that is also there. Here there is some ulcerative lesions, there's pustula. All of these are different types of rash. There's even lymph nodes. So that means that these symptoms are still found, are being reported, right? So that means that the case is actually going on. Let's get the distribution or the frequency, right? Just the most commonest symptoms. Same symptoms and signs. So some of them are not symptoms, some of them are signs. Like a rash is not a symptom, it's a sign because you are seeing it. Okay, perfect. So let's see how to do that. To do that is very simple. All we have to do is that we just have to get that column. So this column here, symptoms, you have to convert this entire stuff to list. But if I do this, we are going to have some zeros there, right? Some NaN there, right? So because of the NaN, I'm going to replace all the NaN with, so fill now. I'm going to fill all the NaS with 0. There isn't a lot of NaNs because most of the data are confidential and then we don't actually work on this. I want to fill this with 0, right? This particular type of 0 with O. Then I'll just go with this. If I go back again and I check it out, so all those ones are now zeros. Perfect. Now let's put this entire stuff into a document option so that we can just plot it out. So dot join, right? I'm putting the entire stuff into this particular option here. So I'm joining the entire stuff here. Perfect. And now I can convert this one into a docs that I can plot. So in case I want to plot it, I have this simple function which we worked on some time ago. So we are using this plot here. Let me bring the plot. So perfect. So we have gotten it. So we are using a simple plot. So we are using word cloud to plot it. So there's a simple plot to plot it, and I can just plot it out. So we are using word cloud. So word cloud. Now pass in my doc. So if I pass in this docs, it's going to give us our plot. And as you can see, the bigger the letter, that means that the most commonest word there. So genital ulcers are very common for monkeypox. There is ulcer lesions. There is also ulcerative lesions, right? And then ulcerative lesions are very common, right? Very nice. Not very nice, but very explanatory. Now we can also use collections. So from collections import counter. We are using counter from collections to help us also get the distribution. It's another way. Then we already have our docs like this, right? So I can actually split the entire stuff. So dot split. If I split, it's going to give us an array like this, and now I can just use counter to get the frequency. So this is going to be the word frequency for the entire stuff. So word frequency for the symptoms, and now I can just go with word frequency dot most common, let's go with most common 10. And now we have the most commonest 10 words there. So we are 0 is out because we don't need 0. But we have lesions, which is one of the most commonest words. That's why you could see it as big here, right? So there was lesions, very big. There is genital, as you could see. That's also another common symptom there. Something have to do with the genital because of the mode of transmission. There's ulcer and endostatic, right? So this is one of the ways of getting the word frequency, right? Very simple. Let's do the final one on the dates. So this is going to be the something like on the number of cases per day, right? So you want to know number of cases per day and then how to spread this, like more like time series, right? Then the next time in the next session we'll try and see how to plot it on an actual map. So how do you get this one? So first of all, we'll be converting our column, which is this column. So we have this. If I go back and I just go with the head, or let's go with the columns. If I go with the columns, you can see that we have some options there. Not columns. Columns is an attribute, not a function. Okay, so perfect. So we see that we have date confirmed. We have date confirmed, we have date onset, we have date hospitalization, we have, there are lots of things you can do. So we'll be continuing to explore them later on as we move on, right? So this is not the end of it. So let's pick the date confirmation, right? Perfect. And we're going to plot it to see how it is spreading. So we can also go back again and then just go with this option. You see that there's also travel history location, so you can know which countries the people are coming from, right? To know which countries to avoid and which countries not to avoid. But let's work on the date. So if I go back to this option, I go with my date confirmation, right? This option here. Perfect. So this is well. So I have to convert this entire stuff into date time. So pd dot to date time. Now this is going to be converted to date time. I think daytime. We forgot to do this option. Yeah. But now this is in daytime. So now since this is in daytime, I can get which particular day is most common, which particular day and a trend. So let's plot on the trend first. Right. So perfect. So now since we have converted it to data frame, we can also work on it. But let's plot it first, right? So this is going to be something simple. So this option here. Right, so group by the date confirmation, the status, and then I'm going to plot it with a bar chart, right? Like as you can see, as is beginning of this month of May, as it goes on, it's going to spread up and up, right? I can also do this option, and instead of plotting it with this option, I can plot it with a line plot, so you see the trend of how it is going. So this is the trend of how it is going, right? So in May, around the beginning of May, then it's continuing to going up and up and up, right? As you can see, it is spreading up and up. You can actually use Plotly to also plot it to make it more nicer, which you'll be doing another time. So let's see which of these days, right? We already have the trend. You have seen the distribution per number of cases per time, so it is spreading upwards. Let's also see which day are being affected, which particular day. Is it weekends? And this type day, right? Day. So is it weekends or weekdays, right? So that we know some stuff from it. So I'll copy and paste the code there because of the time. Then we move on and explain it. So it's going to be this option. Yep. So we are just converting to daytime. And then after converting to daytime, we are going to pick that particular date and then a day name, right? Because that's what we want to get, whether it's weekend or weekday. And now we can see from here we have our simple plot here, right? So Mondays, Wednesdays. So Mondays have the highest dates of confirmation because most people don't go to hospitals during weekdays. That's why Saturdays and Sundays are less. And then Mondays, people most often go to the hospitals, right? So let's do another same plot again with plot. Let's do it as kind is equal to bar and now you can see it well. So as you can see from our plots, that most of the time Mondays are the days that are affected, the most of the cases are confirmed, right? So because people go to the hospital over the weekend. We can also do the same thing we did for the onset, right? There is also the onset in our data set. So it rhymes. Let's go back again, and now you can see it here, right? So mostly on Fridays, right? That is when it's onset based on the data set we have. You can also check for the hospitalization when people go to the hospital, or entry rather. And you can see that it's mostly on Wednesdays, right? So this is going to be plotted like this option here. Dot plot. The kind is going to be bar. As you can see from our plots here, that most people go on Wednesdays, right? That is the date entry, right? So that's something very simple we have done in this wonderful tutorial. I know I was rushing at the end because of the time, but thank you for watching this tutorial. So we have seen how to explore the monkeypox outbreak. We've seen how to answer some of the questions. In our next session, we'll be trying to do some interesting analysis. So thank you for watching. See you in the next session. Stay blessed, and check the link below for more materials. See you another time. Bye.